So we're almost at the half hour, so I think we can go ahead and get started. So thanks everyone for attending. So today we're going to talk about how you can create and manage virtual Kubernetes clusters on Amazon EKS. So of course, as a lot of you know and probably are experiencing every day, today Kubernetes has become almost a de facto standard if you're using containerized applications. And there's several good reasons, right? So it's interesting to see the journey, the history of what's happened in just the last, 5 or so years, right? So certainly Kubernetes is the one major architectural paradigm for the DevOps age. It definitely allows us to use other CNCF products, other open source technologies, which are becoming more and more, again, standards in cloud native applications. And then leveraging containers at scale, leveraging microservices at scale, it's a platform designed for this, right? So several good reasons for the broad adoption, for the excitement around Kubernetes. And as you probably know, but at the same time, and if for those of you already using EKS or any other form of Kubernetes, it's not simple, right? It's not easy. There are a lot of problems to be solved. There are a lot of things to be built on Kubernetes. One comment we hear from customers often is even the managed Kubernetes services leave a lot else for the users, the customers to manage, right? So we're going to talk about some of that. We're going to focus more on what's layered above the control plane than just talking about bringing up a Kubernetes control plane, because there's several good ways, stable ways of doing that today. So in terms of an agenda, we'll go through EKS quickly. We're just going to cover, given the short time, we'll just do some basic coverage of what EKS provides. We'll take a look at one way of provisioning EKS. There's several options out there. I'll show you what we do, from Nirmata. And then we'll talk about how you can make EKS consumable, how your dev teams or different product teams can use EKS or other Kubernetes platforms at scale within an enterprise. So just a quick introduction. I'm the founder and CEO at Nirmata. We're a management plane for Kubernetes. We operate on EKS or any other cloud provider, including on-prem. And we've been in the container Kubernetes ecosystem for a while. We've started in 2013. So really exciting to see the opportunities, the usage, the traction we're getting on not just on AWS, but across the board as Kubernetes sort of spreads into pretty much every form of deployment. All right, so let's go through what EKS provides, right? So as it is a managed Kubernetes service, and as with other managed Kubernetes service, EKS, its role is to bring up a control plane for Kubernetes. Later on, I have an architecture slide on Kubernetes, but just at a very high level, you have the control plane components, like the scheduler, ACD, other things, and then you have the worker nodes where your applications are running, right? So the EKS role is to bring up the control plane. In terms of the features, what it does, besides bringing up the control plane, of course, it's well integrated with AWS's IAM. So if you're using that for your security, for your permissions, there are ways to even plug it in directly into kubectl, makes that pretty seamless, fairly easy to use. Things like logging, monitoring, you can use CloudTrail, you can for that, right? So again, as you're bringing up clusters and workloads, that's an important portion of your deployment to solve, not just for the cluster components, for the worker nodes, but also for your applications. And then on the networking and storage, as you would see with infrastructure providers, of course, you want to make sure you're using native networking and native storage. So with, and of course, with Kubernetes, you can install other plugins or other CNI and CSI components, but there are AWS services for these, and it makes sense to leverage those and take advantage of those, right? So there's the AWS CNI for networking. It includes, there's VPC networking support. There's also ELB support. So if you have a load balancer service, this works, seamlessly. You can get an ELB, an application load balancer, or an ELB for your service. There's also things like the app mesh, which is a service mesh, kind of like Istio, but the AWS form of that, which it integrates with. And there's also a service registry. So similar to at a high level what console can do in terms of storing configurations, things like that, but an AWS service. On the storage side, the most common way you will use storage in EKS is through EBS, right? So if you are already using block storage, which you would on an AWS EC2 instance, you can also now attach that and use that with PVCs, with persistent volume in Kubernetes itself. So that whole life cycle can be automated. It will just attach those volumes to your storage for your containers and pods as required. And these are still in alpha the last time I checked, but there are CSI drivers, plugins coming for EFS and also for HPC file systems based on Lustre, right? So lots of options on networking, storage, monitoring, logging, security, and all of these are well integrated with AWS. At a high level, the architecture looks something like this. So you spin up your EKS instance. So AWS will provision nodes for like the control plane for you. And this includes all of the scheduling, the orchestration components for Kubernetes itself, including the API server. You can get a public or private endpoint. This is a cool feature in AWS. Some of the other cloud providers don't have this yet. But in AWS, you can now get a private endpoint. So it's only within your VPC. It's not accessible through the public internet. With some of the other cloud providers, it would be a public endpoint. It's well secured because Kubernetes does secure the API server through X509 certificates, but it's public, right? So that's something to keep in mind. And then your worker nodes, you have a lot of flexibility in how you bring up your worker nodes. What we do, and I'll show you some screenshots. We don't have enough time for live demos in these sessions, but happy to follow up later with these. But through screenshots, you'll see in Nirmata, you can either bring up Spot instances, you can bring up other instances, or just through AWS tools and even through CloudFormation templates, you can bring up different nodes, attach them into your control plane, and that forms your overall cluster, right? So what you get from this is now you get an API server, you get capacity to run your applications, and you can start deploying Kubernetes applications on that, right? So a lot of enterprises, a lot of customers that we start working with, they start with this. But what starts happening is you want to enable self-service for your developers, or your product teams. So very often now you end up with several smaller clusters, and that creates some challenges for management, for common services, for security, things like that, which is what we're going to talk about, in terms of virtual clusters and how those can help solve and address these problems. All right, so just let's walk through what it takes, and I'm going to use Nirmata, which is our product for the provisioning, but there's also EKS, CTL, or Cuddle, however you want to pronounce it, which is a pretty good tool. It's a CLI-based tool. It's a little bit more opinionated than if you just are using CloudFormation and other things, but it will bring up a cluster. It'll bring up even a VPC, and there's some options and flexibility in there. But in Nirmata, what you would do, and here you see there's several ways to provision clusters. We integrate with pretty much all major cloud providers, or you can spin up your own custom clusters. You would fill out some parameters. So I just went through this yesterday and picked our sort of VPC and some of the details for how you want to configure EKS. And then there's more information on the worker node. So you're kind of giving the instance types, things like that. And then you can go grab a coffee at this point because it takes about 10-15 minutes to bring up the control plane through EKS, right? But really the flow in Nirmata, what we've done is it's fully automated. There's no multiple hops. You don't have to go to different consoles. So the idea is through an API, through your own catalog, if you're providing this to your other teams, you can spin up clusters as needed, right? So at the end of, in that 10-15 minutes, what you'll end up with is something like this. This is, of course, in my AWS dashboard. You see it's created a single node cluster. That's what I did for this demo. It also, one interesting feature that we've added, Remember I mentioned that AWS supports both public and private endpoints for the API. So what we do is we bring up a public endpoint first, and if you say, make my endpoint private, we will configure the worker node, drop in the Nirmata controller, and then we'll switch that endpoint to be private. So the advantage here is now your endpoint is within your VPC. You can't access it from outside, and it automatically is available in your network. But this whole flow we've fully automated, and it's basically a single click. So once that's done, this is what the same cluster looks like in Nirmata, right? So we're showing, of course, a lot of information. That alarm is, I think there were no storage classes or something configured. That's why it's showing an alarm. There's policies you can drop in. So right now they're not configured on this cluster. You can drill down. You can see, exactly what's running where. You can even get to, in Nirmata, we allow full access to the YAMLs if you want to do, edit things at that level. You don't have to. But the nice thing is all of this is validated and before it's sent back to the cluster, right? So that's really, in terms of provisioning the cluster, bringing up the cluster, that's what it would look like. Takes about 10, 15 minutes, like I said, but it's a fairly straightforward, seamless process to go through. All right, so let's switch now to virtual clusters. And once you have, EKS up and running, why bother with virtual clusters? Why do anything else, right? So if you think about it, what is virtualization good for, right? Why do we have virtual networks? Why do we have virtual storage? Why do we have virtual compute, right? So fundamentally, in technology, virtualization means almost to have a software-defined form of something. So now you have APIs through which you can start communicating with that, right? And the idea is there's no significant difference to the end user when you're using the virtual form of your resource, whatever that might be, from using the actual physical form of the resource. So now, obviously, there's a lot of benefits there already. And you want to make sure that with virtualization, you're providing the right level of isolation, the right level of security. And just like with compute virtualization, if folks remember the history, there's like type 1 and type 2 virtualization, some virtualization. In fact, containers were called like OS virtualization for a long time, right? Before Docker emerged and containers became popular as we know them today, this was really just OS virtualization where you would take one operating system and slice it up into several different segments for web hosting and for other applications. So it's just, again, a different level of isolation. And even containers as we run them today, you can think of them as a form of virtualization, right? So really, why do this? If you look at just the history in technology, anything that's virtual, that's software defined, becomes easier to use, right? So virtual machines, to get to order one, to rack and stack it, to power it, to do all of that is difficult, takes time. Virtual, or physical machines, I meant to say, all of that takes time. But if you go to a virtual machine, in a few clicks, you can get a machine up and running. Same thing with network, same thing with storage. And also, virtualization makes things easier to share. It's software defined, right? You have an API endpoint. You can access it through that. You can share it through that. So there's advantages there already. And it's also optimizing the resource usage underneath. So Kubernetes, given its sort of pedigree, its origins from Google, it was designed to schedule at scale, right? So if you're using several small clusters, you're missing out on some of the resource optimization benefits that you could get from Kubernetes. Of course, the trade-off is, you get hard isolation, you get, security, but it's the same kind of thing with, that you could discuss with virtual machines or virtual networks or any of these technologies, right? And finally, the more interesting thing is, without virtualization, there would be no cloud computing, right? So if you think about only when we got to virtual computers in our virtual networks, virtual computers, virtual storage, now we have cloud computing and on-demand compute. So virtualization really enables new ways, new paradigms of using things. new usage models, new chargeback models. It's very interesting to think about. Again, if you have something which is complex, which is difficult to bring up, to secure, to manage, like a Kubernetes cluster, why not use virtualization to make that simpler, right? Why not enable new models, new ways of giving this to your teams, to your developers with some secure isolation and make it easier to share. So that's kind of what we'll talk about, is how can that be achieved in Kubernetes? What are the different options, and what can that enable for you and for your deployments? So just to kind of quickly recap, so much like with any other technology, if you start thinking about virtualizing Kubernetes, immediately the benefits are much easier to use for developers, for end users. Secondly, there's a clear now separation of roles. So your dev team can focus on what they do best. Your ops team can be responsible for operating, governing, providing security, providing visibility, policy management, all of that for their clusters. You get better resource utilization regardless of where you're running. So now you can have a larger pool of compute. You can use more heterogeneous workloads on Kubernetes. You can even enable, like whether it's AI ML through Kubeflow, whether it's serverless with Knative, you can do all of that on the same set of resources, right? And then now you have a smaller set of clusters. You will still need multiple clusters. You probably want to isolate production, so you'll have dev test staging production, but you'll have a fewer set of clusters versus hundreds of clusters, or depending on your company size or the number of teams and the number of users that are using this, right? And then again, for different in terms of different usage patterns, as soon as our customers start using some of these features, the next thing they ask is, hey, why does my team need to select where exactly this gets deployed? For certain workloads, can something else decide, right? So now you have different models which can be enabled. Maybe you want, for continuity, maybe you want to automatically clone a namespace, you want to move things around. But the user of the namespace, the user of that virtual cluster, doesn't really need to know or care how things are done underneath, right? So now you can create these additional layers of abstraction for your end users itself. All right, so let's jump into the how, and we'll look at the sort of prevalent strategies for virtualizing Kubernetes that are out there. So first off, this is like a very high-level architecture with some of the main components of Kubernetes on the control plane. So the control plane is what EKS brings up, by the way, and the worker nodes is what also you would enable through CloudFormation or through Nirmata, attach them into your control plane. But you have ACD, the API server, controllers, schedulers running in the control plane, which is where Kubernetes does the bulk of the orchestration and management. And then you bring up worker nodes to deploy your applications. So if you think about this as a layered architecture, and it's and if you from an architecture point of view, it's nice to kind of think of things in a layered view. So really, you have your management plane, which is tools like Nirmata and some of our competitors, or you're using native kubectl and other tools. You have a control plane, which is Kubernetes itself. And then you have the data plane, which roughly translates to where your applications are running, where your data and your workloads are, right? So the first way of virtualizing Kubernetes is control plane virtualization. So here what you do is really for every end user, you're giving them their own control plane. So this requires some changes into the control plane. It's not something that's supported by EKS or other managed services today, but there are proposals. There's a pretty good proposal which is being reviewed. So by the way, if you're interested in this topic, I have some references. There's a multi-tenancy working group in CNCF, which is a great place to discuss these. There's ongoing proposals being reviewed. So there's a proposal from Alibaba where as a service provider, what they have done is they have added constructs to Kubernetes to virtualize the control plane completely. So each one of their tenants, their virtual clusters, gets their own API server, but they're sharing a scheduler across all of those virtual control planes, right? So it's a slight deviation from the standard Kubernetes as we know it, but it's a nice design. It's a good way of virtualizing the control plane. And there are some advantages to that, right? Because now if you need hard multi-tenancy, if you're a service provider or you're operating at a very large scale, now you can have each one of your tenants gets their own API server. They could even have different versions of CRDs. They get their own cluster-wide resources. So several advantages to this approach. But again, it's not standard. It's not widely supported. Still being reviewed in some of the working groups and SIGs. So, but if you're willing to try it out and experiment, certainly, look up the multi-tenancy working group, and in their GitHub repo, there's CRDs and other things you can use. There's a good white paper from Fei and others at Alibaba where they cover this in detail, right? But there is another way which is more suitable for most enterprises, and this is what I'll cover in a little bit more detail. And this is what we do at Nirmata, right? So if you look at the definition of namespaces in Kubernetes, interestingly, this is word for word the definition in the Kubernetes docs, where they say, Kubernetes supports multiple virtual clusters, and the way that it's done is through namespaces, right? So that sounds fantastic. Our problems are solved. We can just use namespaces, and we have virtual clusters. Well, not exactly. There's a lot more to it than that. Because if you think about, okay, I have my workload, I put that in a namespace. So far you have naming isolation in the API server. The other thing you need to do is you need to have proper RBAC so that the user of that namespace cannot interfere with the user of some other namespace. Then you also have to configure network policies if you want to isolate things at the network level, which if you have multiple tenants, you probably do. Then very importantly, you need to add limits and quotas. You need to make sure you have, limit ranges. So every pod has the right, limit request, the limit, also like the requests and limits for every resources that you're making available. And finally, very importantly, you probably want to run pod security policies, which it's controlling. You don't want one tenant to get root access and escape into the file system and then be able to impact other tenants, right? So very quickly, you see namespaces are really not virtual clusters. It's namespaces plus all of these Kubernetes constructs. The good news is Kubernetes has everything you need to create virtual clusters. The bad news is it's not that easy to configure and manage at scale, right? So, and the story gets a little bit more interesting because now if you have a team, they probably want their own monitoring dashboard. They probably want their own logging, which is isolated from other applications, other teams. You want some change management, whether it's GitOps, Jenkins, whatever you're using, to be able to manage that. You need to configure secrets access for those applications. You need more security controls, like in terms of running if you're using Twistlock or Aquasec or any of these security tools. You need an ingress for the applications within those namespaces. You need to think about backups and DR if these are production applications. And also, increasingly, microservices style applications are using service mesh. So you probably want to allow that as an option, right? So again, the good news is all of this can be done and can be limited to work with a namespace. The not so good news is it's not that easy to do and manage at scale, especially if you want to do this in a self-service manner. So this is one of our customers, and this is the set of tools that they ended up with. No kind of, the vendors they picked, we didn't influence, but really it gives you an idea of what this looks like when you want to do it across teams and at scale. So going into the solutions available today, if you're kind of trying to do this through namespace, and there are some things being, again, in the same multi-tenant working group being proposed, being discussed. So definitely, if you're interested in this, if you have use cases, that's the right place to go and contribute. The two interesting proposals there's something called a tenant CRD. So everything now, of course, the next level of things in Kubernetes are all CRDs. So a tenant CRD, as the name indicates, allows you to define a tenant and then certain resources, certain abstractions for that tenant. There's also a proposal for a hierarchy of namespaces where you can copy things. It will automatically, the controller the HNC controller will automatically copy things across namespaces. That allows, different, for a single tenant, now you can have your set of namespaces, and you can have an admin for that as well, right? And then, the other way, and this is what we do with Nirmata today, is we just use policies that you configure in the management plane that we apply into Kubernetes. Now, as one of these proposals or all of these mature, we will support different alternatives. And of course, if there's standards, we will support those. And we are, also kind of trying to think about what's the best way, what's the best combination of these approaches for real world use cases for customers, right? So let's take a quick look at how this works, what this could look like. And again, I'm going to show the demo kind of screenshots are through Nirmata, but of course, if you go directly use kubectl, all of this can be done. So if you're interested in seeing how you can do this independently, talk to me at lunch or after the session, and we can discuss some of that. So one of the things we use is Kyverno, which is an open source policy management framework. This is something that we are also working with the policy working group on. And there is another solution called OPA or OPA, which is Open Policy Agent. What that does is it lets you write policies in a language called Rego. There's also Gatekeeper, which is a related project. The reason why we built Kyverno is we wanted something which is extremely Kubernetes native, CRDs. We also, Kyverno policies are CRDs, policy results are events. So everything is, if you're familiar with Kubernetes, it's extremely simple to use Kyverno itself. So underneath the covers, this is what we're using, and this is how we're applying things. You can go use Kyverno open source. So just look up kyverno.io and try that out too. But let me show you what this looks like in action, right? So I'm going to show, instead of the UI, we're going to look at this from the Nirmata CLI. So we have NCTL, which is our command line. The main abstractions in Nirmata, you can think of, you have a catalog for your teams, or you can have catalogs for different teams. You have clusters, you have environments. Environments are what will map to virtual clusters. So really the idea here is, now if I am a developer, I can see which clusters I've been given access to. Here I see the list of clusters I have. And then what I can do is I can say, create a new virtual cluster, right? And notice here, the advantages, I'm saying all I have to specify is I want 2 vCPUs and 32 GB of memory. Other than that, I don't care, about provisioning Kubernetes, managing Kubernetes. My ops team is going to take care of that for me. But this is how I would, as a dev team or as a developer, how I would request my virtual cluster. So what happens behind the scenes is there's a lot of heavy lifting that Nirmata will do, depending on where you're deploying Kubernetes, whether it's on EKS or other endpoints, and it will configure all the constructs we just talked about. So at the end of that, what happens here is, now you have the context. Nirmata will get the kube config. It will automatically set that in your local kubectl. So now you have the context, and if I do the last command that we're showing over here, if I do get context, I have that demo virtual cluster. It maps directly to a namespace, as you see, because that virtual cluster is limited to that one namespace now, right? And if I try to run an application, it's the same experience I would get as with any Kubernetes, nothing really fancy over here. I can see my pods, I can manage my pods, do whatever I wish. But if I try to say, give me all the namespaces, it'll say, no, you can't do that because you are limited to your own virtual cluster, right? So similarly, of course, this is a very simple example, but there's a lot of other checks. There's network policies, there's the pod security policies, everything else we talked about.